Hello students. Today let us come to the next topic, mean life. Okay. So what is mean life? The average life of an atom of radioactive substance is equal to the sum of lifetimes of the atoms divided by the total number of atoms. That is the average life or mean life, which is equal to average or mean means what we'll do. For example, there are some numbers like 1 2 3 4. Find the mean or average means what we'll do, sum of these all quantities 1 plus 2 plus 3 plus 4 by total number of quantities 1 2 3 4. Is it not? This is only the average, right? So here is also the mean life or average life of and radioactive substance is nothing but sum of the lifetimes of all atoms. Why lifetimes? Means we are going with mean life. So sum of the lifetimes of all the atoms in the radioactive substance by total number of atoms, we call that as a mean life. Okay, so here to derive the formula for mean life, we have to take the basic formula, that is we know n is equal to n naught e power minus lambda t. Okay, right. So here sum of lifetimes of all atoms by total number of atoms means what? Here the lifetime of the atoms decreases or disintegrates continuously. Is it not? If it is a radioactive substance, what happens? It disintegrates the radioactivity continuously. So what happens here? We have to take the disintegration rate of the molecules. Okay, so therefore the rate of disintegration can be written as rate of disintegration means nothing but dN by dt, right? Okay, rate of disintegration with respect to time only it disintegrates, right? So dN by dt can be written as d by dt of n means we know n naught e power minus lambda t. Okay, so dN by dt is we know that n naught means which is a number of atoms at the initial time. So it is the number of atoms means which is nothing but the constant. It is a number, right? So we can write this as n naught into d by dt of e power minus lambda t. So this can be written as dN by dt, which is equal to n naught. For this minus lambda, you know how to write e power minus lambda t. Okay, so therefore we can write dN, which is equal to lambda n naught e power minus lambda t dt numerically. That's why we are not taking minus here. Okay, it is numerically we can take this as a plus, right? So this gives the number of atoms disintegrated between time t and t plus dt, which gives the number of atoms disintegrated between time t and t plus dt, right? So if each atom out of these dn, okay, if each atom out of these dn atoms which can disintegrated in time dt had lifetimes of t seconds, means that is we can write the sum of lifetimes of dn atoms is given by sum of lifetimes of dn atoms is dn into t. Okay, sum of lifetimes of number of atoms means lifetimes into number of atoms only, na? That only we are doing here dn into t. In order to find out the total lifetime of all the atoms of radioactive substances, total means we have to disintegrate it, right? Total lifetime of all the atoms means we have to integrate it, right? So to integrate, so in order to find out the total lifetime of all the atoms. Total lifetime means we have to integrate, right? Integrate between what are the limits? Means integration from lower limit to highest upper limit, that is nothing but 0 to infinity. So we have to integrate between the limits 0 to infinity. Therefore what we get is nothing but integral of 0 to infinity dn into t. Okay, so now the average lifetime can be written as, we know, Ta is equal to, okay, what is the formula? The sum of total number of atoms, the sum of lifetimes of total number of atoms, right? This is only the sum of lifetimes of total number of atoms. So 0 to infinity dn into t, okay, by total number of atoms. Is it not? Total number of atoms. So we know that total number of atoms is nothing but integral 0 to infinity, okay, dn into t by n naught. Right? So this can be written as, the Ta can be written as integral 0 to infinity. We know the formula for dn. Dn is equal to what we get, lambda n naught e power minus lambda t dt, right? So we'll get this as lambda n naught e power minus lambda t dt, okay, into here it is t, right, by n naught. This is for this total one. So n naught gets cancelled, and which can be written as lambda. Here is the decay constant, so we can write this as 0 to infinity e power, what we get here, lambda is constant, n naught gets cancelled, we get e power minus lambda t into t dt. Okay, then solving the integration part, right? By solving the integration part, what we get is nothing but Ta is equal to lambda into e power minus lambda t by minus lambda, first one, okay, e power minus lambda t by minus lambda into t, minus, again we have to go with integration, right, e power minus lambda t by by minus lambda, okay, into dt. The limits are from 0 to infinity. Okay, so by integrating this we get like this. So what we get in the next step is lambda e power minus lambda t by minus lambda into t, this one, minus e power minus lambda for dt minus lambda t by lambda square, we are doing for this, right, 0 to infinity. So here lambda, I am taking lambda minus lambda as common here by lambda, so minus and lambda I am taking. So what we get is e power minus lambda t into t minus e power minus lambda t by lambda into 0 to infinity. Okay, right. So here by applying, or we can write minus 1 by lambda, okay, and e power minus lambda t is also common here. So what we get is t and t minus 1 by lambda, 0 to infinity, okay, and then we can write this as 1 by lambda e power minus lambda t into, I am writing this as lambda t, okay, lambda t minus lambda t plus 1, 0 to infinity, taking lambda as LCM for this, right? So by applying these limits, what we get finally is 1 by lambda. Therefore we can write T average is equal to 1 by lambda. Okay, that is the average life or half life of a radioactive substance T average is equal to what? 1 by lambda. Now we'll go the relation between half-life and average life. Okay, relation between half-life and average life is nothing but we know that T half is equal to 0.693 by lambda. Is it not? So we can write this as a 0.693 by 1 by lambda. Here it is 1 by lambda, right? 1 by lambda can be written as what? TA. So 1 by lambda can be written as TA. Therefore, this is the relation between half-life and what? Average life. So therefore, we can write T half is equal to 0.693 T average. 0.693 T average. This is the relation. Okay, so T average is nothing but 1 by lambda. Lambda is the decay constant here, and T, the relation between half-life and mean life of a radioactive substance is T half is equal to 0.693 TA. Okay, this relation is very important relation. Okay.